Thanks. Dear students, welcome to the third live session of the course Solar Energy Engineering and Technology. So in this session, primarily we'll be discussing briefly about the content cover in module 9, 10, 11, and 12. So in module 9, we have discussed about solar air heaters. In module 10, solar concentrating collectors were elaborated. In module 11, thermal energy storage were discussed. In module 12, emerging solar energy technologies were presented. Let us discuss one by one briefly what are the contents covered in those modules. In lecture 1 of module 9, primarily fundamentals of solar air heaters were discussed, followed by performance analysis and different types of solar air heaters and its importance and how these solar air heaters can be employed for different applications. In lecture 2 of module 9, we have discussed testing of solar air heaters. Say, for example, the figure we have shown here is a setup by which solar air heaters can be tested. So for that, we need a solar air heater which need to be tested, a blower because we need to blow the air, then rotameter to control the or to know the airflow meter, and then some kind of regulating valve, then air conditioning apparatus and mixing vanes. And of course, we need some more instrumentation to measure temperature and flow rates. So controlled air is passed through these solar air heaters, and we have to install sufficient number of thermocouples to measure the inlet fluid temperature and outlet fluid temperature. Since this is air and particles are in dispersed mode, so we need to use mixing vanes so that we get a uniform temperature. And of course, at the end, we have 3 different thermocouples, and finally we are taking the average of all those temperatures recorded by those thermocouples. And these experiments were performed at different mass flow rates to characterize a solar air heater. For in case of liquid flat plate collector, this is not the case. So single mass flow rate will give the characteristics of a liquid flat plate collector. And after that, we have studied the application of solar air heaters in drying of agricultural products, process heat in industry, and power generation. So while discussing drying of agricultural products, we have also covered drying characteristics curve and drying calculation by considering a fruits. So how this drying or drying methodology has to be considered, and finally, what will be the size of a dryer to meet a specific requirement. In lecture 1 of module 10, primarily we have discussed about solar concentrating collectors, starting with fundamentals, classifications which are based on reflecting type utilizing mirrors, refracting type utilizing Fresnel lenses, imaging type, it may be line focused or maybe point focused. So in case of line focused, we use tracking system, a single axis tracking system, but in case of point focus, we use double axis tracking system. And then concentration ratios, which tells about operating temperature as well. So as concentration ratio increases, the operating temperature also increases. For flat plate collector, the concentration ratio is 1. That has already been discussed in the thermal energy calculations lectures. And kind of trackings, as I said, like single axis tracking, double axis tracking. So these are the part of classification. And then we have discussed basic energy balance. From that, we have calculated what will be the useful heat gain. So the figure what is shown here, it includes this reflector where solar radiation falls and is reflected to the absorber. The tube what you are seeing, this is the tube through which heat transfer fluid flows, and this is heated up. And this is a solar field piping. So that way, n number of, or say, no, based on the requirement, many parabolic trough collectors are connected in series and parallel. So what we are really interested out of this analysis is the amount of useful heat gain. So which can be represented mathematically by QU is equal to AA multiplied by S minus UL by C TPM minus TA. So all the parameters were discussed in the class, but what I would like to emphasize about C. So C is concentration ratio. So if we consider the case for flat plate collector, this value of C is equal to 1. Then accordingly this can be modified. But as we are increasing the concentration ratios, then no C value will be increasing. You can find out the QU, which is nothing but useful heat gain. The analysis of parabolic trough calculators, collectors and heat transfer characteristics were also presented. And this is how we have represented this concentration ratio, which is defined as effective aperture area to the absorber area. And for parabolic trough, this can be represented by something like this: W minus D naught divided by pi into D naught. So W is something like, if we draw a line from here to here, this W, and D naught is the outer diameter of this tube. So that's how it is defined as C. In lecture 2 of module 10, we have primarily discussed about working principle of different concentrating collectors and its technologies, and also the comparison of concentrating collectors. Some of the key points are power towers and troughs are best suited for large grid connected power projects in the range of 20 to 200 megawatt. These or engine systems are modular and can be used in single disk applications or grouped in disk farms to create large multi-megawatt projects. Parabolic trough plants are the most mature solar power technology available today. So power towers with low cost and efficient thermal storage promise to offer dispatchable, high capacity factor, solar only power plants in the near future. These are the observations we could figure it out based on the analysis and studies. In lecture 1 of module 11, primarily we have discussed thermal energy storage, which includes sensible heat storage, latent heat storage, and thermochemical storage systems. In sensible heat storage, energy is stored when there is no change of phase, only temperature rise. So for example, if we consider water as a source, then no temperature may be varying from in the range where phase change doesn't occur. For latent heat of fusion, we always go for phase change. Here, latent heat of fusion are employed. And in case of thermochemical storage, so we use heat of solar thermal process to happen a chemical reaction. And if we need the stored energy, then we provide some form of thermal energy again to get the original energy back. In lecture 2 of module 11, we have discussed solar pond, its fundamentals, working principles. Also, we have discussed temperature profiles and energy balance, operational shortcomings, type of solar ponds, and its application. In lecture 1 of module 12, emerging solar energy technologies were discussed, which are like perovskite solar cells, organic solar cells, dye-sensitized solar cells, quantum dot solar cells, and also advanced technologies like photovoltaic thermal technology and solar fuels were discussed in this module. In lecture 2 of module 12, solar energy applications in solar distillation, solar cookers, solar refrigeration and air conditioning systems, solar space heating and cooling, solar thermal devices for low, medium, and high temperature applications. These were extensively studied in this module.
Hello, sir. Hello, sir.
Yes.
Yes, sir. I ask one question, sir. In your presentation slide, you clearly explain the latent heat depend on the temperature difference. It is but you give option. It depends on mass, density, and all of things. So please explain. According to your
please say again.
according to your
lecture, can you write it here in the set box?
Okay, sir. I write.
Because so that the way you are saying it's very difficult. Your voice is breaking.
Okay, sir.
So latent heat explain this. What latent you see? Latent heat means what we are doing, heat of fusion. I will explain very precisely. Say for example, for drying of say paddy. So we need to dry at approximately 633 degrees Celsius, right? So if we are giving more heat, then no, this quality will not retain. And if we provide insufficient heat, again, no quality that moisture will be there. Then there will be a probability of fungal attack, right? Now the concern is like what temperature we should give. Okay, so once we identify the appropriate material which melts at close to 63, that material we should use, and we provide some kind of energy to melt it, and then when it melts, then it will provide the latent heat of fusion to the material. And that's how its drying will happen. So when we say latent heat, it's a M into L. Okay, so mass of the substance multiplied by L is the latent heat of fusion. I hope you got the answer.
Okay, sir. Sir, one more question. I write in NPTEL lecture. There is a maximum temperature obtained from the parabolic disk type of collector. You show approximately 1000 degrees centigrade, and another place you show maximum temperature. Solar power tower there is also obtained maximum temperature is 1000 degrees centigrade. But at last slide in your lecture, I think 23, 32 or 33 lecture, last lecture, there is a, in end of the lecture, you show comparison of all type of collector. There is a mention solar this type of collector give approximately 750 degrees centigrade. But in your assignment, you show the answer is solar power tower give maximum temperature. So how, sir, it is? Because of in comparison slide in your lecture comparison slide, you show maximum power, maximum output temperature is this type of collector, parabolic dish type of collector.
So see here.
But your option is solar power tower.
Did you mention this there in the discussion forum?
Yes, yes, I discuss timing with timing. At this time slide, at this slide you show maximum temperature of power.
Did you discuss in the discussion forum? Then what reply you got from the discussion forum?
We did not get my last question reply. Before that, you give me reply and give me all of numerical solutions, all of things you provide me. It is for thank you for that.
That will be given to you. Don't worry. That all the things will be clarified. But see, but condition is something like that. So for your understanding, I am giving some information. So when you are using parabolic trough, then your temperature is less than 400 degrees Celsius, or maximum 400 degrees Celsius you can achieve, right?
Sir, so parabolic this type of collector.
Wait, I'm coming to your point.
Okay.
I'm comparing your things, right?
Okay.
So when you are considering heliostat, right?
Yes.
So what solar radiation falls, and they know it's bounced back to the absorber. Okay.
Yes.
So that's the heliostat. So its the temperature varies. Okay. What kind of heliostat you are using, that depends. So it is something like you cannot quantify, very pinpointed temperature. So you can see some ranges. Is it not?
Yeah.
Of course, no, the solar radiation flux is varying. So this is not fixed. So maximum when you say for example, even then we cannot go 13 solar constant value, right?
Yes.
1.67 we never achieved. So that way,
okay.
These are fluctuating. So we cannot, when we say it's a comparative range only, you can say. So it's not a very pinpointed temperature. And solar this temperature is also very, very high.
Yes.
Okay. So these things are relative, but no, when we compare, then there is a scale. Like it should go in this range. Okay. So that's how we need to compare. And again, if you see solar furnace, these are very high temperature. So how many collectors you are focusing? Then no, you can go up to more than 500, 1500 degrees C. So this is a very high temperature, right? So solar furnaces are also applied in many of the places. Okay. So now this parabolic trough, and then when you are talking about Starling engine and all, it's external combustion engine. So this is quite expensive, and it has not reached the maturity level.
Okay.
The way this parabolic trough has reached. Okay. So that's why you'll not see in the market or in the places where normally the solar energy is harvested. But the people have demonstrated its workability. Right? So that's how you need to see an exact temperature scale. Maybe I'll see it again and I'll share with you in the discussion forum.
Okay. Because of due to this, my question become wrong because of I select parabolic this type of. But your answer is the parabolic. Solar power tower is give maximum output temperature.
I'll see it. Maybe if required, then answer can be reverted back.
Sir, in assignment 11, first question, the capacity of sensible heat storage depends on temperature difference in your lecture, and mention a formula E is equal to M integration of T1 to T2 Cp dt. This is the formula you show in your lecture. Assignment 11. But your option is given to the temperature difference and mass of material and specific heat. All of above.
Yeah, of course, specific heat is constant, but mass and delta T is fine. Mass and delta T.
MCP is the heat capacity there.
Yeah, heat capacity, but not this 10% difference. Cp anyway is constant, right? The amount of mass. Normally it's a mass. It's a mass.
Sir, as mass increases, then storage energy also increases. As mass of fluid or any
that's
substance.
The disadvantage. No, that's a disadvantage of a sensible storage system.
Yes. So
that's the disadvantage of a sensible heat storage system. So when disadvantage compared to our latent heat storage system.
Okay. So according to in a lecture, we select the temperature difference only because of you mention in a formula also E is equal to m integration of T1 to T2 CPdT. So we
mass is also responsible, na?
Yes. So we choose because only temperature difference, but your answer is
same energy storage.
Yes, but your answer is.
Let me clear to you.
Okay.
For the same energy storage,
yes,
you need higher mass compared to latent storage. Okay. So mass is also important. Mass and delta.
Okay. Okay. Thank you, sir.
Yeah.
I have only 2 doubts, sir.
Fine. Thank you very much.
Sir, one more question regarding examination. There is a, sir, we use calculator 991 ms from starting to till now. So this calculator is allowed in the examination hall or only online calculator?
I think you will get the information when you will get the exam hall. This is the hall ticket that will be displayed there. I think calculator, digital calculator will be there.
Because of we get a link for digital calculator before 2 or 3 days before. If they give at starting of the lecture, starting of this course, then I will practice approximately 2 months on that online calculator. So it is difficult for that day exam in examination.
Okay. Fine, I'll bring the information to the concerned people. But if they have already decided, then I cannot do anything.
And sir, one more thing, there is a big formulas somewhere in some lectures.
No need to worry. The formula, you don't have to worry much about big formulas. But fundamental things you must know.
Yes.
Big formulas, if I am asking, then formula is also given to you.
Okay, formula is given in the question.
Yeah, that way you should prepare. Because my intention is not to memorize the very long.
Yes, because of there is a 100 question and only 3 hours. If like as a gate exam is 2 marks question is something big question, 2 marks question. But this is a I think 1 marks question and 100 question in within 3 hours.
In assignment also, I think you don't have to remember all those mathematical expressions. The kind of question we said, all the informations are given in the question itself.
Okay.
So that way you can prepare.
Okay. Thank you, sir. Okay, thank you, sir. I leave the meeting.
Yeah. Thank you so much, sir.
Okay.
Any other questions from any other students? If you have any questions, you may ask. Okay. So there is a question like any material for studying for exam. So all the no, I suggest you read all the lectures properly, and if you have done sincerely all the assignments, then I think you don't have any issues. Very easily you can solve those problems. And that there is no something like exam material I cannot provide. So exam material means the content what I have shared with you through video lectures. So one of the student is asking what is the meaning of solar panel efficiency. So you know solar cell efficiency. So when we are connecting many cells in a frame and we connect series and parallel, okay, then it becomes no panel. So when we are making panels, then of course there will be some losses. So when we consider solar cells, then it is output by input. So what is input? Input is your solar radiation multiplied by area, and output is your what? If you use PV, then you can write voltage current multiplication. And if you consider fill factor, then again you have to consider fill factor as well. So in case of modules or panels, so there will be some losses. So that's how module efficiency is somewhat lower than cell efficiency, right? Hope you got the correct answer. So one student has asked one question: how to get right answers procedure for assignments. What is this? I could not get it. How to get right answers procedure. So right answer is right answer. There is no procedure to get right answers. So if you are doing well and your way of doing is correct, because anyway all the questions are MCQ. So it's like yes or no kind. If you click the correct one, then you will get the correct answer. There is no partial marking. What is the most efficient type of material of which are solar panels? So even though some materials are very efficient, but these are very costly as well. Like gallium arsenide is very good material for solar cell or solar panels. Its efficiency is quite impressive. But no, this cannot be used because of its cost and availability of the material. So because of that, more than 90% material is silicon based. So this is one question answer. When you track the solar power, we can consider only 150 degree or for measuring. This is what 150 degree for measuring. I don't know what kind of question it is. When you track the solar power. See, tracking is something like technically, if you have analyzed it or learned it, like tracking means sun is moving from east to west, right? And if your things are stationary, then what happens? Only you'll get very small time to, or say very less time to get exposed with the high solar intensity. So if you could track the sun with respect to the time, then you can maximize your efficiency. Okay, so see, once it is like it is moving from here to here, at the same time your system is also moving something like this. And then sometimes what happens, you need to move this way as well. Okay, say for example, when we are talking about line focus system, that means two type of tracking is there, two axis tracking. One is something like this and other one is like this. Okay, so that you'll have two different kind of tracking, and its degree is concerned like of course that you can decide how much variation is required. Okay, and these are also location specific. If you have any other questions, please ask. Otherwise, I am going to close this session in 5 minutes. If there is no question, then I am closing the session. So thank you very much for coming live and clearing your doubts. So I wish all the best to all the students, those who are writing the exam. Thank you very much. All the best.